In this lesson, we will explore different mathematical operators on list objects or list variables. We will also see built-in Python functions available for the list object, and we will see functions or methods available in the list class. Let's start the discussion by defining two lists. We can apply plus operator between two list objects, and the effect will be the list concatenation. Very much like we have string concatenation, where two strings are joined together using the plus operator. Similarly, over here the list A and B will concatenate and the result will be a bigger list. Let's print the result. And you can see the variable C is also a list, and it has elements from list A and then from B. Now let's apply asterisk operator between a list object and a positive integer, for example a asterisk 3. We know in case of string that string gets repeated 3 times, and we will have the similar effect over here. The elements inside the list A will get repeated 3 times, and that will be the result in variable C. We can also apply relational operators between two list objects. For example, A equal B means if the two lists are exactly equal or not. You can see it is printed as false, and if I apply the equality operator between two exactly equal lists, it will be printed as true. We can also apply greater than or less than operator between two list objects. For A greater than B, the decision will be made based on first element of both of the lists. It is printed as false because the first element of list A is 2, while the first element of list B is 3, so A greater than B is false. If the first element of both lists are same, then decision will be made on the basis of the second element of both of the lists. The second element of list A is 4, which is greater than the second element of list B, so this must print true this time. There is also a possibility of having an empty list. It means there is no element inside the list. Let's print that. Let's also print the length of list A. You can see the list is printed as empty list and the length of the list is 0. We will shortly see what can be the use of an empty list. There is another way of defining an empty list, and that is by using the keyword list followed by two round brackets. This is basically a constructor which is used to create a list object, and if we are not providing any input argument, it will create an empty list. If you are not comfortable with the term constructor, just recall that we can convert one data type into another data type. For example, a float can be converted into an integer, and that was done by using the keyword int. And that int is also a constructor which will construct an integer value from the input argument. So in case of list over here, we will see in a while that we can provide some sequence or collection as the input argument, and that will be converted into a list object. But if we are not providing any input argument, the list constructed will be an empty list. Now we will explore different functions or methods available in the list class. We have not created or discussed the classes in general, but remember everything in Python is an object of some class. An integer is an object of integer class, and so as a float is an object of float class. In those classes there can be some methods or functions which can be applied on the objects of that class. Why we have different functions or methods for the list? These functions or methods are used to manipulate lists, for example adding or removing different elements from the list, counting some values in the list, or maybe finding the index of some element inside the list. We can do these things without using the list functions because we know we can have a for loop and we can process the complete list and we can get any kind of information from the list by our own logic. But these functions available in the list class help us in a way that commonly needed information from the list can be obtained easily by using these functions instead of writing our own logic. So these functions provide easiness and efficient way of our logic development. If you can recall, we created an object of complex class in one of the starting videos, and on that object we can apply dot conjugate method to get the conjugate of complex number. The methods in a class are applied on the object using the dot notation. So over here if I am writing a dot, you can see over here these are different methods or functions which I can apply on A because A is of list data type. So the first function is append, and we have to pass in one object or simply one element as the input argument of this function. For example, I am providing 100 as the input argument. So this input argument 100 will be added into the list A as the last element of the list. So let's print A. And you can see that 100 is added at the end of the list. Now let's also see what can be the practical use of this append function. Suppose I want to take different numbers from the user and I want to store all of those inside a list, and I don't know how many numbers user will be entering. So maybe I can have a condition that if user enters -1, that's the indication of ending the process, and before that all numbers entered by the user should be stored inside the list. So for this case, I can start with an empty list and then we can have a while loop. Maybe we can have infinite while loop. Inside the while loop, we can take the number from the user. If the number entered by the user is -1, meaning that he is done with entering the numbers, we can use a break statement to end the while loop. And if that is not -1, then I have to put it inside the list, and for that I can use the append function. So the list was empty at the beginning, and in each iteration of the while loop, each number entered by the user is appended into the list, and the process will stop when user will enter -1. So outside the while loop, we can print the list to see the values. Let's run the code. I'm entering different values. Now I will enter -1 to end the process, and you can see the 5 values entered are stored inside the list. Now let's see the remaining functions of the list class. The next function is insert function, and it is used to insert a value at some specific location inside the list. Append function was adding the element at the end of the list, but if we have to add the element at some specific location, we can use the insert function, and this function will have two input arguments. The first is the index where we want to insert the element, and the second is the element itself. So 100 should be added on index number 5. You can see that over here. The next function is named as pop. It will pop out one element from the list whose index we are providing as input argument. For example, a.pop1 means the element at index 1, which is 3, will be popped out. You can see 3 is removed from the list. It's not just the value is removed from the list, we can save that popped out value in some variable. For example, n equal to a.pop1 means the element at index number 1 will be popped out, and that will store in variable n. Let's see the value of n. And you can see it is the element popped out from the list. Now we have next function named as remove. As the name suggests, it will remove some element from the list. As the input argument, we need to specify not the index, but the element we want to remove from the list. For example, this a.remove7 will remove 7 from the list. You can see there are two 7s inside the list. So if that is the case, only the first element will be removed. You can see the last 7 is over there, but the first 7, which was the third last element of the original list, has been removed. Then we have a function named as count. As the input argument, we have to pass in some element, and this function will return the count of that element inside the list. This function is returning that value, so we must assign it to some variable. There are two 7s in the list, and you can see the correct output. If the element is not present in the list, the count function will return 0. Now there is a function named as index. We have to pass in an element as the input argument, and this function will return the index of that element. If there are multiple occurrences of that element in the list, this function will return the index of the first occurrence of that element. For example, for 7, it will return the index of this 7, which is the first one. The index of 7 is 6. The next function is clear function. It doesn't take any input argument, and it removes all elements from the list, means the list will become an empty list. Another function is named as reverse. This will not take any input argument, and it will reverse the order of the list. You can see after applying the function, the elements of the list are in reverse order. Now let's see some possible uses of these functions. We did a task previously to find if a number is palindrome number or not. A number is a palindrome number if it is same as the number in the reverse order. For example, 252 is a palindrome number because if I reverse this number, again I will have 252. On the other hand, 251 is not a palindrome number. We did this task previously by separating each digit of the number and then creating a reverse of the number. And finally was a comparison of the original number and the reverse number. Now let's see it can be done in a much simpler way because we have a reverse function available for the list class. So if I can convert the digits of a number into a list, then I can simply check if that list is same as the reverse version of the list, then the number will be the palindrome number. So I'm defining some number over here. Now as we can convert different data types into other data types, we can convert one data type into list data type using the keyword list, which we discussed a while ago. But a number cannot be converted into a list because a number is a single object and we can only convert other sequences or collections into lists and not the single objects like int or float. So if I will pass n as the input argument, it will generate an error. The solution is that we can convert a number into string data type using the keyword str. String is a sequence of characters and that can be converted into a list. Let's print the list A. You can see it is a list and elements are the digits of the original number, but not in integer format but in string format. Now it's very simple. I can reverse the list. You can see the list is reversed. By applying the reverse function, the original list is changed. So to compare it with the original list, I can recreate the original list from the number. And then I can simply compare the two lists. So if the list is same as the reverse version of the list, it means the number is palindrome. And if not, the number is not palindrome. So you can see the number is not palindrome. Let's change the value of n to some palindrome number. And now the output is palindrome. This function reverse when applied on the list will change the original list, and that's why we recreated the list on line number 4. But if you recall from the last lesson where we studied the slicing of a list, when a slice is extracted from the list, the original list remains unchanged. And if you remember, we studied that we can extract the complete list in the reverse order using this notation. We are not providing the start and the stop parameter, and the step is set to -1. Now this will not change the original list A, and we can assign it to some other variable, for example b, and now we can simply compare the list A and B, or maybe we can directly write inside the if condition. Now let's move to the next function of the list class. I am defining another list as B. The next function is extend function. When it is applied on some list, for example list A over here, as the input argument we have to pass in another list, for example B over here. This function will insert the elements of input argument list B at the end of the list A. You can see that over here. Now this is exactly same as of the concatenation operation, which can be performed using the plus operator. There is a little difference however. In case of the plus operator, for example C equal to A plus B, the lists A and B remain unchanged and the result is stored inside the list C. But with the extend function, the original list A is updated to the new list. So depending upon our requirement of the logic, we can use the plus operator or the extend function. This is exactly what we observed in case of the reverse function and the list slicing using the -1 step size. By using the reverse function, the original list is changed to the reverse version of the list, while in case of list slicing, the original list remains unchanged. Now the next function in the list class is sort function. As the name suggests, it will sort the elements of the list. Sorting is one very important operation in different data science applications. This function will sort the elements in ascending order. You can see now the list is sorted. If you have to sort the list in reverse order, you can do it by specifying one optional input argument named as reverse, and the default value of the reverse is equal to false. So by default, when reverse is false, the list is sorted in the ascending order. But if I make that reverse equal to true, now the list will be sorted in the reverse order. These were the functions available in the list class, and now we will see some built-in functions of the Python itself which can be used on the list objects. We will not be using the dot notation now. The first function is the length function. We can pass in the list as the input argument, and we saw that previously that this function will return the length of the list, which is the number of elements inside the list. The next built-in function of the Python is main, which will return the minimum element from the list. Let's print the result of this function. You can see the minimum value inside the list is true, and it is printed as true correctly. Likewise, we have a function named as max, and it will return the maximum element of the list, which is 12 for this case, and you can see the correct result. There is another function named as sum, and it will return the sum of all elements inside the list. There is also a built-in Python function for sorting the elements of the list. We saw a while ago that we have a function named as sort inside the list class, and we use it like a.sort, but we also have a built-in Python function for this purpose. The function name is sorted. We will pass in the list as the input argument. If you will print the list A, it will be in the original shape, because this function sorted does not change the original list, but it returns a new sorted list. So I should assign that to some variable, for example B. I am printing both list A and list B. And you can see after applying the function, the list A is in the original form and we have the list B as sorted list. So again, you can see as per requirement of your logic, if you need to sort the original list, you can use the sort function of the list class. But if you want to keep the original list as it is and need a new list in the sorted form, then you can use this built-in sorted function. Again, if you have to sort the list in the reverse order, you can set the parameter reverse equal to true for this case as well. Next is the keyword named as del. It's not a function, but a keyword or statement, which is used to delete a variable. It can be variable of any data type. So if I write del space A, and now I'm printing the value of list A, you can see there is an error that name A is not defined because the variable A is deleted. For list, there can be a better use of this del. Instead of deleting the complete list, I can specify some element of the list and it will delete only that element from the list. For example, A0 will delete the element at index 0, which is 2 over here, and you can see that. The good thing is that instead of one specific element, we can specify some slice of the list and that slice will get deleted from the original list. So this A0:2 means the index 0 and 1, which are these two elements 2 and 3. You can see those two elements are deleted from the list. If I simply write a colon inside the list slicing, it means I am not providing the start and the stop of the list slice, so that will be taken as the default value, and it actually means the complete list elements. So it means I am selecting all list elements and I am deleting those, and this time you will see an empty list because all elements were deleted but the list is not deleted. Now another built-in function that can be used on list object is named as all. It will return true if all elements of the list are true. Now true means that they are not false. So anything other than false or 0 is treated as true. So at this stage there is no 0 or false in the list. So this all A must return true. But if there is any 0 or false inside the list, this function will return false. Like all, there is a function named as any. This function will return true if there is at least one true value inside the list. Or you can say if there is at least one value in the list other than false or 0. So at this stage, we have many values which are not false. So this should return true. And now if we have this case where we don't have any value other than false or 0, so this function would return false. Now let's see the lab manual. Here I have provided the detail of list class methods. Then there is detail of built-in Python functions for list. Now let's do this task. It says that create a list of 20 random numbers between 1 to 50. We can do it using a for loop or a while loop. Then the program must create another list which will be the list of only prime numbers from the original list. Let's do that over here. I will start with empty list. Now I will have 20 iterations of the for loop because I need 20 elements inside the list. I will create a random integer between 1 and 50. And I will simply append that into the list. So at the end of the for loop, the list A will have 20 elements and all will be between 1 and 50 randomly. Let's print that first. You can see these are 20 randomly generated values. Now the task was to generate another list by selecting only the prime numbers from the list A. For that I can again start with an empty list. And now I should iterate over all elements of the list A. This loop variable I will be the element of list A in each iteration of the loop. I need to check if that I is a prime number or not. And for that we have to check if there is any factor from 2 to square root of that number. We discussed earlier that if there is no factor till the square root of a number, there won't be any after that. So I'm importing the square root function. I will use another for loop over here to see if there is any factor from 2 to square root of variable I. If there is a factor, it means the variable I is not a prime number, so I can use a break statement to end the for loop, and then I can have an else statement of the for loop, which means that the break statement is not executed, and that means there was no factor found, meaning that I is a prime number, so I can simply append that I into the list prime. Let's print the prime list. Let's run the code. There is an error because I should have imported the math module, so I will correct that. And now you can see the 20 numbers in the original list, and out of those, these 5 were the prime numbers. Let's run it again. And this time there were 3 prime numbers in the list. Let's run it one more time, and now I think we have 8 prime numbers in the list. Now the next task is having many parts. Here you have to utilize your knowledge of built-in list class function and use them appropriately. Let me explain the task. You will start with some list. You can have these 20 values inside the list, or maybe you can have more or less values, and then you have to complete the parts of this task without using any for loop or the while loop, but you have to use the list class functions intelligently. For example, the first part says that you have to find the index of maximum value inside the list. We know we can find the maximum value using the built-in Python function named as max. So that will give us the maximum value inside the list. And then we can use the index function of the list class to find the index of that value. So this will be the solution of this part. Then you have few other parts which you have to solve using the same approach. Now let's move ahead. If I have to fill a list with well-defined pattern, for example numbers like 0, 1, 2, 3 till 9, then instead of writing those numbers by myself, I should use range function to generate those numbers. And then I can apply the list constructor on that range function to convert that into a list. So I can do it like this. Now suppose I have to fill one list with all odd numbers from 1 to 50, I can very easily do it like this. Now we will explore some functions which are available in the random module which can be applied on the list. I am defining a list with some values. In random module, there is a function named as choice. You can also see choices over there. We'll see that in a while. But what the function choice does is, it will pick one element from the list randomly. We have to pass in the list as the input argument, and this function will return a randomly chosen element from the list. Let's print that. The function has chosen the element false randomly from the list. If we run it again, this time 66 is chosen, and this time element 1 is chosen. Now there is a function in the random module named as sample. It will take two input arguments. First is the sequence, which is list over here, and second is the number of elements we want to pick from the list. We can say it is the sample size. The function choice was choosing one element from the list, and this function sample will choose a random sample from the list. Let's run that. As you can see, the output sample is a list and it has three elements which are chosen randomly. This time different elements are chosen. Now let's see the function choices available in the random module. Here again we will provide the first input argument as the list, and then there can be an optional input arguments of weights by which we can assign some weights to the elements of the list. So if some element is assigned some higher weight, the probability of its selection will be higher. I will not use that. But then there is another optional input argument named as k, and that basically represents the number of elements we want to select from the list. This looks same as in case of sample function, but there is a difference. In case of a sample, all elements chosen will be unique, but in case of choices, there can be repeated elements. If you have done some probability questions, I hope you would have seen these cases, like a bin having some balls of different colors and then choosing some balls from the bin. There can be two ways of choosing the balls, one without replacement and one with replacement. So the function sample is selection without replacement. So if one element is selected in the sample, it will not be selected again, unless we might have another copy of the same element in the list. But in case of choices, one element is selected from the list, and in the second selection, the same element can again be chosen. So let's see the output of both functions. Both have returned unique values this time. Let's run it again, and this time you can see the choices has selected 3 two times, but the function sample can never have this scenario. Let's run it one more time, and this time choices has selected the element false 2 times. And this time the element 4.5 is chosen all 3 times. Another function in the random module is named as shuffle. It will take the list as the input argument, and if we print that, it is printed as none because this function does not return anything, but it updates the list A by shuffling the elements inside that randomly. So instead of printing the output, let's print the list A. So you can see it has the same elements as of the original list, but the elements are shuffled randomly. There can be some good use of these random functions for the list objects. Let's say I want to generate two integers both between 1 and 6. I can do it very easily using the randint function of the random module. But if my requirement is that the two numbers should be random, but they should also be unique, meaning that A and B should not be same, it's very easy to see that there is a chance that the second number B will get the same value as A. So what can be the solution? One solution can be that we keep generating the random number B until we get something different than what is inside A. So I can use a while loop over here that while B is same as A, we will keep generating B. Now outside the while loop, I'm sure the B is having a different value from A. Now what if I have to generate a third number between 1 and 6 again, and again it should be different from A and B, so I can generate that number. And again I should use a while loop that if it is same as A or B, I should generate it again. Now this is not a very good way of doing this. For example, if I have to generate 10 random numbers with a condition that all should be different and all should be supposed between 1 and 50. So if I have to use this approach, I will have to use a while loop for each new number, and there will be so many iterations of the while loop just to generate a different random number. Let's do it in a better way. I can generate a list of numbers from 1 to 50 in order. I know those are numbers from 1 to 50 and there is no repeating value. So what I should simply do is, I will select a sample of size 10 from this list, and as we saw earlier, that will be a sample of non-repeating values. So these are 10 random numbers and all are different from each other. There might be another way as well, where after creating the list A, having the numbers from 1 to 50, we can shuffle the list, and with that the list elements are shuffled, but there is no repeating value. Now I don't know which is the first element of the list and so on the other elements, so I can pick the first 10 elements from the list and that will do the job. I can do it using the list slicing. I can even omit the start variable, because if we do not provide the start variable, that is taken as the first value by default. Now let's do some tasks of the lab manual. This task is related to the result of Computer Programming 1 course or any other course. The program will take in the marks of all students. It will display the average marks. It should display the number of failing students. Then it should display the highest marks and the roll number of the student who obtained that highest mark. Then it should also display the lowest marks and the roll number of the student who obtained the lowest marks. Your program can first ask for the number of students registered in that course, and then it will take the marks of all of those students, and then it should display the result in a proper format. This task says that we have to generate a list of 20 numbers and the numbers will be random numbers from 1 to 10. Then the program should generate another list and that will have 10 values in a way that first value will indicate the number of ones in the original list and the second value will indicate the number of twos in the original list and so on till the 10th value will indicate the number of tens in the original list. Let's do it over here. I will start with the empty list. I have to fill in 20 numbers, so I will have a for loop of 20 iterations. In each iteration, I will append a value randomly between 1 and 10. So at the end of the for loop, I have the list with 20 random values between 1 and 10. Of course, there are repeating values in this list, and that's what we have to count and generate the second list. So I will start again with the empty list. It will have 10 values, so I can have a for loop and I can have loop variable from 1 to 10. So the range function is from 1 to 11. Inside the for loop, the loop variable I is 1 in the first iteration and I have to count number of ones in list A and I have to append that value in list B. So I can very easily do it like that. So in each iteration, next value is counted and appended into the list B. Let's print that. Let's run the code. The first list is the random list. Then in second list, this first element 3 means there are 3 ones in the first list. You can see those. And this 1 is the third element, which means there is 1 3 in the first list. Then this last 2 means there are 2 10s in the first list. And this 0 means there is no 8 in the list. The next task says that you have to take an integer from the user and then the program should generate a list of all factors of that integer. So let's take the integer from the user. I will start with the empty list. There can be the factors from 1 to the number itself, so I should have a for loop from 1 to that number. And I will check if the variable I is factor of n, then I should append that into the list. And then outside the for loop we can print that. Let's enter 50 and this is the list of all factors of 50. Now the next task is tricky. It says that you have to generate a list of 100 numbers and the numbers will be either 0 or 1 only. And then from that list, you have to find the longest run of 0. The longest run means the longest number of consecutive zeros in the list. I will not create the list of 100 zeros or 1 randomly. That is something you can do very easily. But the next logic of finding the longest run is a complex logic. So I'm creating a list by myself with different zeros and ones. This is the longest run of zeros, which is having the size 4. So what can be the logic to find this number? We can find the occurrences of the consecutive zeros, we can count those consecutive zeros, and we can put those counts of the consecutive zeros inside another list, and then we can simply find the maximum value of that list. For example, for this list, this is the first occurrence of consecutive zeros. So these are 2 zeros, then again we have 2 zeros, then we have 4 zeros, and then once again we have 2 zeros. So let's make it 3 zeros instead. So we need to find the count of those consecutive zeros. I am creating an empty list in which I will be storing those counts. Now I will iterate the list A. If the list element is 0, I can increment the count variable. At this stage, this count will return the total number of zeros in the list, but that's not what we want. Consider this first occurrence of zeros. These are 2 zeros. The count will be 2 on the 4th iteration. After the zeros, when there comes a 1, that indicates the end of consecutive zeros. So if the list element is not 0, which means it is 1, it would indicate that the consecutive zeros have ended. So I can append that count into the list. Secondly, I should reset the count variable so that it should count the next occurrence of consecutive zeros. Let's see what is stored in the list. The first two are zeros, which is basically because of these first two ones. Because inside the for loop, the if condition is false for these two ones, the count variable is 0, and that 0 is appended into the list 2 times, meaning that there is 0 number of consecutive zeros. And then for these 2 zeros, we have a 2 over here. Then for the next 2 zeros, we have this number 2. Then for these 3 ones, we have these 2 zeros, which means there is 0 numbers of consecutive zeros. So firstly, we should consider that 0 numbers of consecutive zeros is something we should not append into the list. So we should apply a condition over here that if the count variable is not 0, only then append that value into the list. So now if we run the code, we can see 2 to 4, which are for these consecutive zeros. But this last consecutive zeros are not added into the list. Now what is the reason for that? The reason is that the count of zeros is added into the list whenever 1 is observed, because we are doing that in the else block. After the last 3 consecutive zeros, there was no 1, so that count was not added into the list. Although the count is calculated, but that is not added. I can confirm that by adding a 1 at the end of the list, and now if we run the code, you can see all counts of the consecutive zeros in the list. But in a general case, we might not have the 1 at the end of the list, so maybe we can add a 1 by ourselves to make sure that there is 1 at the end of the list. Or there can be a second solution that outside the for loop, we can check if the last element of the list is 0, which means that the last count of consecutive zeros is not included in the list, but it is calculated in the count variable. So we can simply append that into the list. So let's verify by running the code. There is no 1 at the end of the list, and we have the correct count of consecutive zeros inside the list. Now to find the maximum run of the zeros, I can simply pick the maximum value of the zero count list. Now let's add 2 more zeros at the end of the list so that the last consecutive zeros are now 5, and the result is correct. Now this task says that we have a list, maybe entered by the user, or maybe you can insert the values by yourself, and the task is to remove all duplicates from the list. So here I am defining a list. It has duplicate values. So the final goal is that I should get this list where the repeating values are not included. I will do it by starting with an empty list, then I will iterate over the elements of the original list, and the condition is very simple. If the element of list A is already in list B, I should not append that into the list B. Or I could write it like, if the element I is not in the list B, so I should append the value into list B. So next time, if there will be same value of I, it will not get appended into the list. Let's print the result. And you can see the correct output. I have done many tasks and now it's your turn to do one review question. The question says that you will take numeric values from the user until he enters -1. Now that's very simple. You can take those and store them in a list. Then the program will generate and display 3 lists. The first will be the list of values which are less than the mean of the values entered by the user. Then the second list will be list of all values which are equal to the mean of the values entered by the user. There might not be any value which is equal to the mean of the values, but if there is any, that should be inside the second list. Then the third list must be the list of all values which are greater than the mean value. So in short, all values inside the list are to be displayed, but the order will be different from the original list. So that's all from this lesson. Thanks for watching.